It shouldn't have happened. That Homo sapiens, our species, survived. For 200,000 years, the odds have been against us.
We're not indestructible. There are evolutionary dead ends. There are some species that don't survive.
Our ancestors not only survived, they spread into every corner of the globe.
Only Homo sapiens were able to migrate in and colonize the world's most difficult terrain.
Even places forbidding to any form of life. They found a way.
If you are not resourceful, you die.
Follow anthropologist Niobe Thompson as he travels the globe, retracing our remarkable human odyssey.
My name is Niobe.
He's looking for echoes of the past in the skills of people living in remote and demanding environments. Conditions our ancestors had to surmount on their journey to everywhere. How did our greatest of grandparents not only survive their treacherous world, but ultimately become our planet's dominant species?
What you really find out, they were capable of amazing things.
The Great Human Odyssey, up next on Nova. Our species, Homo sapiens. There are now more than 7 billion of us living all over the world. In every nook and cranny, on every continent, in places where the living is easy and where it is harsh and unforgiving. We look different, our skin various shades of color. Our children a palette of their parents. But under the skin, our DNA varies only a tiny fraction from person to person because we are the same species, Homo sapiens.
Globally, everyone is Homo sapiens. If we're united by our past, united by our present, we're certainly united by our future.
We evolved for millions of years from more primitive creatures, becoming Homo sapiens only about 200,000 years ago. Until recently, much of our ancestors' early history remained a mystery.
They never left any records for us. No video records, no pictures. What they left for us is their bones.
But now, new discoveries are beginning to reveal their complex evolution, their strategies for survival, and their seemingly relentless drive to reach everywhere. Understanding how our ancestors accomplished this feat is driving anthropologist Niobe Thompson on his own around-the-world journey.
That looks like a hand axe to me.
He's exploring important archaeological sites and observing the world's last hunter-gatherers to understand how our ancestors were able to conquer every environment on Earth.
Our species has the unique ability to live almost anywhere, any climate, any temperature. One species everywhere. That's astonishing. But that's not how our story began. Far from it.
In the beginning, Africa was our only homeland. And East Africa's Great Rift Valley may have been the very place our species evolved. Here, more than 3 million years ago, a creature named Lucy walked upright as we do. Yet her brain was no bigger than an orange, and she climbed trees like an ape. Over time, a bewildering array of ancestors evolved more human-like features, but remained small-brained and very primitive. By 2 million years ago, bigger-brained creatures like Homo erectus emerged, and began making larger and more sophisticated stone tools.
Once they start using stone tools, that means they had access to high energy food that might have triggered the expansion of the brain.
Stone tools helped early humans butcher animals they killed or found. And consuming more meat helped power a growing brain.
That food source is very important to feed our brain, which needs a lot of energy to maintain.
Eventually, there appeared a creature with a brain and body type like ours. Our Homo-sapien ancestors had finally arrived. But uncovering fossil evidence of these early ancestors is extremely rare, as Ethiopian paleontologist Berhane Asfaw knows all too well.
One of the reasons why we are not getting so many humans, the population is so small. It's very small.
And that's why this skull is so important. Discovered near the Ethiopian village of Herto, at 160,000 years old, Herto Man is the most complete early human skull ever found. He was unearthed in the dry Middle Awash region of northern Ethiopia.
Stay this side. See the ridge running up there? All the sandstones in here have fossils. Stay within 100 meters of me. Go have fun.
Over the years, an international research team has found important pre-human fossils in this area of the Rift Valley. Then in 1997, Berhane Asfaw noticed bone fragments that looked distinctly human.
It's a child skull, shattered into over 160 pieces.
Finding fossils crushed into pieces by time and geologic forces is not unusual. So the team was astounded when they found a nearly intact adult skull, which they carefully wrapped for conservation.
Perfect jacket.
Instead of the low forehead and protruding brow ridge of earlier species, Herto Man has a flat face and the distinctive round brain case of Homo sapiens.
The brain has expanded, the face has shrunk. It is basically a brain-dominated individual. All the features that it has is exactly us.
An artist's rendering suggests that Herto Man would have resembled a modern man from Africa. But what do we really know about him? How did he live his life? Today, the Herto region is dry for much of the year and looks like it could hardly support any life. But excavations have uncovered numerous animal remains and stone tools from a time when the valley was far more fertile. The Herto of our ancestors had rich vegetation and a lake that drew prehistoric buffalo, hippos, and other game they hunted for food. The bones of these animals have been unearthed, and they have an important story to tell.
For example, we see this cranium of a hippo, the upper jaw. We see a chop mark, which must have been made using this kind of large cutting tool in order to dismember this hippo. Humans were repeatedly feeding on hippo meat.
Many of the skulls were from hippo calves that were far less dangerous than full-grown hippos. But humans weren't their only hunters. Deadly carnivores stalked the lake, so our ancestors needed to be tightly organized to avoid becoming meals themselves. Archaeologist Jonas Bayen has studied all the Herto finds and can almost visualize how our ancestors must have hunted.
These guys must have come in a team, coming in together, and moving up together. Whatever meat they find, they encounter, they must cut it fast and move out. And that cooperation among the group members must have contributed to their success as humans in that difficult environment.
Hair-toe tools were more versatile than previous types. Different sizes and sharpness for precision and power.
Somebody who makes such kind of tool has an organized brain, hunting together, acting together. And it is that social behavior, social culture, which pushed us, evolve to what we are now.
By 150,000 years ago, our ancestors were living a precarious existence in small bands of hunter-gatherers, scattered across the African continent. 100,000 years later, they are still hunter-gatherers, but now they're on their way to becoming the most dominant species on Earth. How did this remarkable transformation come about?
We have a problem of understanding the power of our own species. Physical powers, and especially the mental powers, that is what we have to understand. We are an incredible construction, Homo sapiens.
But we almost didn't make it. Throughout the years of our ancestors' emergence, there were severe climate changes. Large swaths of Africa became bone dry, forcing animals and people to seek more fertile ground. How did our ancestors survive these environmental crises? What did they do when the food and water ran out? They clearly made it because we are here. The question is, how did they do it? Niobe Thompson has come to southern Africa's Kalahari Desert to meet and observe the San Bushmen.
Niobe. Obi. Yeah. Obi.
Although many of the San have been moved out of their traditional homeland, small groups continue the resilient ways of their ancestors. Anthropologists, like Niobe, have been observing such societies for decades, trying to understand their social, cultural, and spiritual beliefs, and how they live their day-to-day lives, from the food they eat to the natural medicines they use. Living in one of the world's driest environments, members of this group can still survive in traditional ways. Niobe accepts an invitation to follow the men on a hunt. This will give him a rare opportunity to see if these hunters display strategies our ancestors might have used to find food in this desolate landscape. One of the techniques the San are known for is called persistence hunting. Humans are not built to be natural killers like the great carnivores of Africa. They haven't the speed, power, teeth, or claws. We also do not have much body hair, and that's to our advantage. In the hot sun, lions and other fur-covered animals need to release body heat by panting or sweating through their tongues. Humans can sweat from all parts of the body, and by doing so can endure the intense heat longer. Hunters like the San can't outrun faster animals, but they can outlast and exhaust them before making the kill. It is very possible our ancestors hunted just this way. There are few game animals in this area of the desert, but enough so Niobe can observe the San's skills firsthand.
We've been walking for only an hour now, and what I notice is that they're always looking down. They're not scanning the horizon to see the animals. They're looking for their tracks in the sand. It's like they're reading a book.
And they can still find their prey.
Jonas has found a spring hare. They've hooked it through its den using their long hooked stick.
Once they've secured it, they have their dinner. But survival for desert people has always been about finding water.
We all share a voracious appetite for water. Our kidneys were evolved in a jungle environment, and so they're designed to flush 2 liters of water a day. So what would our ancestors have done in a place like this, the Kalahari, which sees no rain for 9 months at a stretch?
The San know the desert plants that have an ability to retain water, like the Kalahari water tulip, which can be shaved and then squeezed for its precious liquid. Wherever and however they find water, the San know how to store it in ostrich egg sip wells for even drier times.
You drill a hole in one end of it, you make it an empty vessel. And if you find a water source, you can easily fill up these ostrich eggshells. And so if you're able to carry around a large number of these ostrich eggshell flasks, you have a constant source of water. You could even, like a Hansel and Gretel, be leaving yourself a pathway of stored water. Then who knows how far you could travel.
Archaeologists have unearthed fragments of ostrich egg sip wells from 100,000 years ago. So the San are indeed using an ancient technology borrowed from the past.
I think this is one of the most remarkable hallmarks of our amazing brains, is that we can easily come up with innovations to move into these extreme environments.
Niobe returns to the village, where women are milling mungungo nuts into a tasty paste. Like wild game, nuts and berries were also the food of our ancestors. But the San are 10,000 generations removed from those ancestors, so their lives are really quite different than they would have been in the past. These desert people have clearly retained the kind of adaptability our ancestors must have possessed to survive in such dry environments. But even this kind of resourcefulness may not have been sufficient. For there were times when drought became so extreme, parts of Africa turned virtually unsustainable for human life.
So in times of great aridity, human populations with their need for water would have just disappeared from large areas of the landscape and shrunk back to the places where they could survive.
Where the drying rivers and disappearing grasslands of the interior made life virtually impossible, some of our ancestors began searching for a place that could sustain them, and they found it by the sea. It was here, along South Africa's rocky coastline, that bands of early humans would discover new sources of nourishment, and possibly something critical about themselves as well. High up in this cliff face, in a cave near Pinnacle Point, Archaeologists are uncovering evidence that around 100,000 years ago, early humans found refuge here, and perhaps ideal conditions for an unprecedented expansion of the human mind. Niobe has come to Pinnacle Point to meet lead archaeologist Curtis Marion.
I thought that coastal life would be a refuge primarily because the sea is still productive.
And the plains beyond the sea were fertile with wild game and edible plants.
So you have the plants, the animals, and the seafood. And those three things together make for the ideal conditions for the refuge.
Curtis Marion has found evidence of several periods of occupation, now made visible in the excavated layers of sediment.
So this is an intact hearth feature, a place where about 80,000 years ago, somebody came in, built a hearth, cooked shellfish, got up and walked away.
The sea was a bountiful resource for fish and shellfish, both nutrient-rich foods for the mind as well as body.
Rather than thinking of it that when we got smart, we noticed that there were all these shellfish lying around and so we started to eat them. Well, maybe it was the other way around. Maybe it was our regular consumption of all those shellfish that provided the nutrients for the brain to become better wired.
Whether it was seafood or just an abundance of all food, ancient humans seem to have thrived here, as evidenced by the many things they left behind.
There are 220,000 plotted finds.
Every individual point contains data about the nature of that artifact.
And every one of these little dots is an object that was relevant to human behavior. So a lithic artifact, a stone tool artifact, a piece of shell, a piece of bone, a piece of ochre.
The team found stone tools typical of those made by early humans. And they also discovered thinner blades made from a stone called silcrete. These slim, sharp points were thought to have been invented thousands of years later. But the team is finding hundreds of them here at Pinnacle Point. Experiments showed that ancient humans heated silcrete to very high temperatures. After the rocks cooled, they could be flaked off in thin, razor-sharp pieces.
They're little tiny blades. And the way they were mounted is you would take a dart, so maybe something made out of bone or wood. You'd grind a slot into it, and then you'd glue these little sharp blades into that. And the whole idea is true projectile technologies, spear throwers or bows and arrows.
Now, humans could stay at a safe distance from their prey and increase their effectiveness as hunters.
A human operating with true projectiles, they can dominate the planet.
To Marion, projectile technology was a major breakthrough.
These are multi-component tools, so you need to know how to make a blade, you need to know how to make the glue to insert it.
We're talking about a process, a recipe, right?
Right. The whole thing is a long recipe that's complex. And how do we pass on recipes? Language, instruction. And so if you don't have language and instruction and the ability to hold a number of data bits in your mind, then you can't put those complex technologies together.
Living amidst the rugged beauty of South Africa's coast, early humans created a new blade technology that reflected the expansion of the human mind. And in another cave, called Blombos, there is evidence of an additional breakthrough. Here, excavators are finding large quantities of ochre, our earliest paint. It's made from crushing rocks containing natural pigments like reddish iron oxide.
You can look at the vast amounts of ochre in here that's been worked to produce powder. to make pigmented compound, a paint essentially, using quite complex chemistry, certainly complex for 100,000 years ago. For what? They didn't eat it, I don't think. They didn't, hunt lions with it. They were probably painting their bodies with it.
The appearance of art has often been linked to the emergence of symbolic language, a critical development in the modernization of our species. And Henshelwood's team has found intriguing carved symbols that were etched on a chunk of ochre 75,000 years ago.
The engravings are quite simple, they're cross-hatchings. Writing's perhaps not quite the right description, but it's certainly a symbol that meant something. So it would have been an early form of communication, or if you want to call it writing. That is a breakthrough. That does not happen at earlier stages.
Do you think that the people in this cave were speaking to each other?
Yeah, absolutely. I think people were talking to each other on a regular basis. How did they transmit all this knowledge about the environment, about which plants you can eat, about which fish is poisonous? They could certainly plan for the future. So these ochres were an important part of life, and they're telling you that the human mind was not just concentrating on getting down and trying to find some food every day, but the human mind was almost as advanced as we are today.
To Henshelwood and other experts, art is the fingerprint of a species becoming modern.
One of the things that being a symbolic animal does is that it allows us to refer to the past, think about the present and what's going on, and to imagine what the future may be and how we may act to ensure our own survival.
To ensure their survival, did humans begin seeking more nourishment from places they had never been before? There is evidence that the South African cave dwellers were eating fish and shellfish that lived deeper in the ocean.
So we need to look at a scenario that people were, in fact, not afraid of the ocean. You would start off with probably the near shore, but over time we can see that they're also going for deep water species like abalone. Abalone are not easy to find unless the water is really, really low. So the possibility is that people could go into the water, they could dive, but you need to go under the water to get those shellfish.
If our ancient ancestors became deep-sea divers, how exactly did they do it? One clue may lie with hunter-gatherers today, who, like the San Bushmen, could give us a glimpse into the past. Niobe has come to remote Tawi-Tawi in the southern Philippines to observe the bajau. The bajau are completely adapted to life by the sea. Their children are taught to swim almost from the moment they are born. This is Santarawi, one of the last of the great bajau divers. As a young man, he could hunt underwater for 5 minutes at a stretch. He can't stay submerged quite as long now, but at age 63, he's still remarkable. Niobe is the first Westerner Santarawi has ever met. But the old diver has agreed to take Niobe deep into the sea to show him his skills.
Bang niya kasusahan no talaw kamarem tahik aku bahala sabay kau maya ma ako panduan ta kamarem tahik. Thank you to go down there. Good.
What the Bajau are masters of is something called breath hold diving. To observe them firsthand, Niobe has trained a long time for this day. Wearing a full wetsuit, he's going to follow Santarawi and his son to a reef about 80 feet below the surface. At this depth, a body no longer floats. The hunters can walk atop the coral. When they're truly hunting, these men would spear fish or catch other sea animals, diving again and again to increase their haul. After 2 minutes, Niobe is desperate for air. But Santarawi is still quite comfortable, even in this intense water pressure. His extraordinary control seems almost superhuman.
People have been diving to 100 meters on one breath, and remember they have to swim back up to the surface again.
That's about 300 feet, almost 4 times deeper than Santarawi is now.
Very, very few terrestrial animals, I think probably none, could do that. We have a diving response that is conserving oxygen for the brain and the heart, the organs that need a constant oxygen supply. It's difficult to understand why we are so good divers if we were not forced by evolution to learn this.
Although it's difficult to tell how extensively ancient South Africans foraged the deep ocean, they clearly gathered enough food to sustain and even grow their population. As a result, people's lives became more stable. And this gave them time to think and create and pass knowledge from one generation to the next.
We're beginning to think about, what is it that makes us human? Well, if you look at Lucy, it's upright walking. That's the feature that we share with it. If you look a little later in time, it's larger brains, stone tools, bodies of modern size and proportion. Then hominids who lived 150, 200,000 years ago, they're beginning to use ochre to decorate their bodies, to decorate each other. They're making very rudimentary art. Once that barrier is broken, then you feel really separate from the rest of the world.
So we didn't go from being totally non-modern to being totally modern overnight. I don't believe in the idea of, let's say, a few mutations in the brain that suddenly made us modern. I think it was an accumulation of modernity that allowed us to have the behavioural adaptations that enabled us to go out of Africa and eventually spread to all the regions where we are today.
By 100,000 years ago, the human population of Africa was small, perhaps no more than 10,000 breeding-age individuals, living in small bands scattered across the continent. They were in the early stages of developing skills that would prove invaluable when they began to leave Africa, probably following migrating animals they hunted for food. But how did our ancestors leave Africa? or more precisely, where? Around the time of our ancestors' emergence, the Sahara Desert had expanded dramatically, and along with the deserts of Arabia, created a formidable barrier between Africa and the rest of the world.
You can see how cut off our ancestors were. This was our original homeland. Now, look at the size of the Sahara and then Arabia. Together, they form a massive obstacle, and yet somehow humans found a way from here to here. We just don't have any idea how they did it.
We know early humans found a way because of an extraordinary discovery near Mount Carmel in Israel. In the 1930s, while exploring caves called Skul and Kafsa, English archaeologist Dorothy Garrod found 10 Homo sapien skeletons, all over 100,000 years old. To this day, these are the oldest human remains ever discovered outside Africa. But how did these people solve the challenge of the Sahara and reach the Middle East? Could they have followed the Nile River Valley north across the desert? Or perhaps crossed the Bab el-Mandeb Strait when sea levels were lower, narrowing the distance from Africa to Arabia? Recent discoveries of hand axes in the Arabian Peninsula may indeed point to the strait as an avenue of migration for early human wanderers. One of those discoveries occurred here at Jebel Faya, an ancient settlement site not far from Dubai. The scientist in charge is German archaeologist Hans-Peter Oepmann. And what his team is discovering under this dry surface tells him this wasn't always a desert. The team has found artifacts from a 10,000-year-old agricultural society. But Oepmann believes they would find evidence of far older occupations if they just dug deeper.
This surface reminded me of the situation which I had before in Oman. And this find made me think that we should go down under the Neolithic. And they started below the Neolithic, and all the way down here, there was nothing.
This is all sterile here.
This was all sterile.
Right.
And they started to complain, why do we dig here? There is nothing. I told them, you go down as far as we can.
What did the workmen think?
Well, they thought he's crazy.
As they dug deeper, they began finding stone tools like this one.
So that looks like a hand axe to me, Hans-Peter.
At 120,000 years old, the axe is about the same age and type as those used by the Skul cave people in Israel. Although they have found no human remains here, Oepmann believes the hand axes prove humans did take advantage of lower sea levels to cross into Arabia from East Africa.
There was a window at the time when the sea level was lowest. But we always think the low sea levels means cold conditions. That's for a while true. While the sea level goes down, it's cold. But as soon as it started to rise, it must be warm already.
And wet.
And wet. With the warmth comes the wet.
Oepmann's team has found evidence that there was once flowing water at Jebel Faya, and this probably attracted animals and humans. In fact, it now seems possible several desert regions may have been far wetter in ancient times. Niobe has come to the University of Hull to meet paleoclimate expert Tom Coulthard. Coulthard has figured out that a shifting monsoon rain cycle may have had a significant effect on ancient Africa.
we've got like a climate model, a paleo-climate model, like the models we use nowadays to model climate change.
Yes.
Okay, but transposed back 125,000 years ago. Every 20,000 years, the Earth kind of wobbles around. So there's kind of a 20,000-year cycle.
It's a regular pattern.
20 to 40,000 years of how far north the monsoon goes. The monsoon belt was probably about 700 kilometres further north than it is at the moment. So whole parts of northern Africa that are present deserts and receive next to no rainfall, we're receiving quite a lot of rainfall, the kind of amount of rainfall we get in London.
This shift essentially eliminated the Sahara Desert as a barrier for humans that were further south in Africa.
That's right. Here we have North Africa. You have this mountain range, and the rain will fall on these mountains, and it wants to flow north. And that's enough water to generate rivers that flow straight across the Sahara.
These rivers may have reached all the way to the Mediterranean, creating green corridors before drying up once again.
What's really interesting is 125,000 years ago is essentially when we first start to see modern humans in North Africa and even the Middle East.
That's right. So this climate shift corresponds with a really interesting time in how we think humans got out of Africa.
Did the school cave humans follow one of these green corridors to reach Israel? We'll probably never know exactly how they got out of Africa. But a bigger question is, did they become the first of our species to begin populating the rest of the world? Or did they leave Africa but die out before getting further than today's Israel? We might know if the school people are our out-of-Africa ancestors if we could recover their DNA and compare it to our own. But DNA this old is extremely difficult to recover.
Over many, many years, many thousands of years, you get a mineralization process. So the once living tissue becomes like a stone. And if it proceeds completely to that state, then of course there is no organic material left. There's no DNA for you to study.
But a recent discovery at Cambridge University may offer some hope. Almost a century after Dorothy Garrod discovered human skeletons in Israel, an exciting new find has brought Niobe here. Looking through the collections, anthropologist Marta Lahr found an old tobacco tin that once belonged to Garrod.
Very smooth. Is that this actually?
And among the bits and pieces, she found an intact tooth.
This whole part was missing, and this.
With a replica of a skull's jawbone, she shows Niobe where the tooth came from.
I couldn't quite safely put it in. It would not have held.
And explains the find's significance.
At the moment, to be certain from archaeology or anthropology, when modern people first left Africa.
But a tooth in good condition can sometimes yield DNA when old bones cannot. And if they got DNA, they might just solve the mystery of the school people.
Imagine if we get genetics out of this.
Lahr has sent the tooth to this man. He's Danish geneticist Eske Villesø, who's made a formidable reputation for decoding ancient DNA. Everyone's genome contains an evolutionary history written in DNA, which is comprised of 4 chemical compounds, abbreviated as A, T, G, and C. Inside our cells, the chemicals line up in pairs along a twisted double helix, creating a biological code that runs our bodies. Patterns in people's DNA differ because of random mutations that can occur when billions of letters of our genetic code get copied and then passed from generation to generation. People who are related will share similar mutation patterns, while those who aren't have fewer similarities. But embedded in everyone's genome are ancient mutation patterns inherited from our very first ancestors in Africa. If Eske can find these patterns in the school DNA, This could mean these are the people who left Africa and became the direct ancestors to everyone in the world. But will the tooth have any DNA left to analyze? At his Copenhagen lab, Eska's team receives the package from Cambridge he's been waiting for.
Så er der skuldertand.
Er det skuldtanden?
Mm.
Jeg skal lige se, hvordan den ser ud.
Forsigtig.
Ja, jeg skal nok være forsigtig. Jeg skal være helt forsigtig her. Jeg skal lige se. Jeg skal bare lige se. Den er. Men, ja. My hands are shaking, right? I mean, when we talk about, now we have to drill. Things can go wrong. I mean, we know that, right? When you cut a tooth, can splinter, whatever, right? Of course we want to do it, and we will do it. Certainly is one of the most important specimens, human specimens, in terms of understanding, the spread of modern humans, and maybe it is the most important specimen, right? So.
After a year of searching for DNA from the tin can tooth, they had their answer.
Udslaget.
Okay.
Det har du alle prøverne, vi har kørt samtidig. Skold har du her.
Hvor skold? Den her?
Ja. Men du har, det her er ancient.
Var det stejt? Det ser sgu ikke dårligt ud, altså.
Against all odds, they got an initial hit of ancient DNA.
Er der ikke sådan en blank?
Jo, det er den der.
Beautiful.
Kan du se, hvor skarpt det er?
Ja.
Det er super degraded.
Beautiful. Super beautiful.
And Niobe is there to share the excitement and see the results for himself.
What you have here is the length of the
This
DNA
is the length of the fragment, so to speak.
This
peak is significant.
This is a marker.
It's a
this
marker.
One. Yeah.
The big spike is merely a marker. The important data is in the small bump next to it, a fragment with a few dozen chemical pairs of what looks like ancient DNA.
That bump is around 40 base pairs, the majority of the height of the top of the bump, right?
It's a short fragment and they will need to recover many more. But this is a promising start.
I mean, how do you feel about this result now?
It's ancient DNA. The question is, what ancient DNA is it, right? I mean, whether it's human that has survived in there. And we can only find that out by sequencing. So, but it looks good.
Okay, good.
Sequencing is a process to reveal the exact order or pattern of the chemical base letters in the recovered sections of DNA. But they will need to sequence many more DNA sections to accurately compare patterns in the school genome with our own. It will be a long process and it may not work, but Eska is pumped up.
I have to get myself a snuff to stand the excitement.
You're not allowed to eat in the lab.
Okay.
But 10 months later, the excitement has vanished.
Jeez. I mean, it's pretty disappointing. I mean, I'll give you that. We could see that the fragmentation of skull was just, of the DNA in skull was just severe. And it's so fragmented that you cannot map it uniquely in the human genome.
But Eska's not prepared to give up.
Even though the chance is not that high, but there's still a chance, I think it's worth struggling until at least there's no more hope.
And Eska does not stay dejected for long. He's already working on another ancient sample from a different part of the world. And this time, he may just crack it. Although the genetic relationship of the school people to us remains elusive, to experts like Burhani Asfar, they are not a mystery. He believes migrations like the school people have been occurring for millions of years.
It's not only one time that these early humans moved out of Africa. They've been doing it continuously. like 2 million years ago, there might have been multiple groups or populations moved into Europe and Asia. Whenever conditions change in these prehistoric people, they are not sentimentally attached to one place. They always follow their food. Then as they are following their food, before they know it, they are far from their place where they used to be.
When Homo sapiens began leaving Africa about 100,000 years ago, they were actually following in the footsteps of more primitive species that had begun migrating over 1 million years ago. By 700,000 years ago, one of these early bands had reached well into Europe and Asia. And by 500,000 years ago, they had spawned 2 human-like species. A group called Denisovans and a robust people called the Neanderthals. Homo sapiens would not evolve until about 200,000 years ago. There is genetic evidence of contact among all 3 species. But the most momentous encounter seems to have been between humans and Neanderthals in the lands of today's Europe. Humans entering Europe about 50,000 years ago found a landscape far different than their African homeland. It was colder, but had bountiful forests, numerous lakes and rivers, a land teeming with wildlife, and even a species of humans that looked and behaved differently. Neanderthals had lived in Europe long before Homo sapiens arrived. But what were they really like? For years, they were depicted as primitive, ape-like and unintelligent. But this turns out to be a very misleading picture.
It's been calculated the absolute volume of Neanderthal brains on average is actually higher than the modern human average. So this is maybe an indication that they were not stupid. They were actually probably quite smart.
At the University of Tübingen, Greek archaeologist Katerina Harvati studies Neanderthal fossils for clues to their way of life and their fate.
The Neanderthal lineage lived in Europe for more than 500,000 years, much more strongly built, with quite wide trunks, wide pelvis, a lot of musculature. And Neanderthals tend to have the body shape that is thought to be cold adapted. Now modern humans coming in, early modern humans coming in, they're looking very much more African or warm adapted, in fact, in their body proportions and facial characteristics and so on. And it did not have any of these skeletal or biological adaptations to the cold.
Neanderthals were also lighter skinned than humans coming out of Africa because of the latitude they evolved in.
In northern latitudes, there's less sunlight hitting our skin. It turns out you have to allow a certain amount of sunlight through to the deeper layers of your skin to synthesize vitamin D. So people like me are mutants. We have light skin because we lived in northern latitudes. We adapted to the new environment.
Neanderthals, without question, knew their environment very well. They were expert hunters, but I don't think any modern human had any illusions about the strength of the Neanderthal. They knew they were attacked, they were probably goners.
But humans arrived in Europe with superior weaponry, like bows and arrows and spears they could throw, while the Neanderthals had only developed thrusting spears.
Modern people rely very much on long-distance weaponry. Neanderthals didn't have this sort of weaponry, and they really had to be extremely fit and extremely strong in order to be able to just pull it off.
It is tempting to assume humans used their superior weaponry to kill off the Neanderthals. But recent genetic findings indicate the two groups were closer than once thought.
We know that many people today have around a 2% input of Neanderthal DNA outside of Africa. So clearly these populations not only met and had offspring, but that DNA came through to the present day.
But does the fact that they interbred tell us something significant about relations between the two groups? Were they hostile or not?
I think it's likely that it wouldn't always have been nice. Just like with modern human groups meeting each other. Sometimes it's nice, but more often it's not peaceful. And it involves different degrees of violence, different degrees of assimilation, different degrees of cooperation, and different degrees of just avoiding each other.
But if we didn't kill them off, why did Neanderthals go extinct while our Homo-sapien ancestors survived? And can modern archaeology shed light on this enduring mystery? There are mountain caves in southern Germany that were once occupied by Neanderthals, abandoned, and then reoccupied by Homo sapiens, creating a kind of lab experiment for archaeologist Nick Conard to compare the two cultures. He's been unearthing artifacts from each occupation and gives Niobe an insight into his discoveries and how he's interpreting those finds.
The last Neanderthal occupation is about here. Starting here, we have modern humans. And what's interesting is when we look at the material culture that the modern humans made and compare it to the material culture that the Neanderthals made, the difference is like day and night. We find essentially no symbolic artifacts with the Neanderthals, and we find the whole spectrum of every imaginable kind of symbolic artifacts as soon as we get to the period with modern humans.
These are the symbolic artifacts Conard's team has been finding. Carved figurines, many out of mammoth tusk ivory. These are among the oldest figurative art ever discovered and reveal important qualities of the people who made them.
They clearly have to do with ideology, perhaps religious beliefs of these people. And there's no question, humans are here doing things that modern humans and no other people had done before.
Among the figurines, Conard's team found some of the earliest musical instruments ever discovered.
When can we prove that people made music? It's here, and it's again in this exact period, slightly in excess of 40,000 years ago. This is a flute 1, so the wing of a swan. You can make one of these in an hour. It's not a problem to make it if you have good stone tools. The key thing is the musical engineering to know the exact dimensions and exactly how to carve the holes. This one was a gigantic surprise for all of us.
It's an ivory flute, and because it's hard and brittle, it would take far greater skill than making a wooden one.
Who would make a flute out of ivory? Whereas this can be done in 1 hour. This takes about 100 if you know what you're doing.
And these are functional flutes. These are actual instruments that we know can play notes.
Oh, definitely. Definitely. You can play absolutely beautiful music on them.
Was music, in your view, an important part of keeping a society together?
Oh, absolutely. I think all of these symbolic artifacts were the glue that held society together. The likelihood that music was played in the caves is 100%. The likelihood that stories were told, that ideas were exchanged, that social interaction was taking place here, in my opinion, is essentially certain.
To the humans who settled in Europe, music and art became the building blocks of a shared culture the Neanderthals may have lacked.
What humans brought with them was imagination. What they brought with them were views of the landscape, of trees, of animals, which were alive. We're the wise people. That's why we're called Homo sapiens. Sapiens means wise. We plan, we think, we imagine, we innovate, and had an ability to communicate that was unimaginable to the Neanderthals.
Just how much different Neanderthals were from Homo sapiens remains controversial. But both species would be put to the test by the onset of sudden periods of intense cold, signs that a new ice age was coming.
These events were often very rapid. We know from climate records that some of them happen in less than 10 years. So the human populations in Western Europe would have seen this incredible chaos. So everything they were familiar with just disappearing. All the plants, all the animals, within a few years.
Neanderthals were cold weather people, used to icy conditions, and as a species had survived twice as long as Homo sapiens. But at the end of this deepest of freezes, it was Neanderthals, not Homo sapiens, that stood on the brink of extinction. On Siberia's northern frontier, Niobe has come to this frigid and desolate spot to meet another unique group of hunter-gatherers. But to find these Arctic nomads, he's had to hitch a ride on a vintage Russian Army tank. This relic of the Cold War is one of the few vehicles capable of plowing through snow and ice to reach one of the world's most unique cultures, the Chukchi reindeer herders. The Chukchi live seasonally, part of the year in settled villages, and the other in the cold, open plain with their reindeer. Niobe has visited the Chukchi before and speaks to them in Russian. As he did with the San Bushmen, he will stay with them to observe their survival skills. The Chukchi have been herders for centuries, moving seasonally with the reindeer that are their prime source of food and clothing. Niobe believes their lifestyle and skills are a reflection of a time when our ancestors somehow survived a global ice age. It is immediately evident they are right at home in a land frozen solid for 9 months of the year. In part, it's because they've been raised here. They have known no other environment. But they have also developed superb cold-adaptive clothing and live in small, heat-saving shelters, both made from animal skins. Temperatures here can drop below -40 degrees. But it's warm and cozy inside the tents, where everyone gathers around the fire for food and warmth. Niobe is one of the few Westerners to have spent time with the Chukchi. Another is Cambridge anthropologist Piers Vitebsky, who lived with the Siberian nomads and explains their ruggedness in simple terms.
How can you put it into words for me?
I suppose the key is you don't have to see the cold as an obstruction or an enemy. Cold actually makes the landscape easier to handle. You can travel immense distances. On a sledge in winter, you can travel hundreds of miles in just a few days. Then there's the food. When you kill animals, the land becomes a gigantic open-air deep freeze. That means you can arrange to ambush, for example, a herd of wandering reindeer, caribou, slaughter them at far greater scale than you could in the summer, and you just pile them up and use them.
A herder's life is unrelenting. But Niobe observes that it's women's work that keeps the community warm.
Проходите, пожалуйста.
Paulina is making a pair of reindeer fur pants for her husband Sasha. To live in the far north, it takes a mastery of fur clothing, and these women have it. It's understanding how that fur changes through the year and then wearing the appropriate hide at the appropriate time that is the genius of this technology.
Most of us see an Arctic environment as utterly hostile and is very dangerous to survival.
I think the key trick is to imitate the animals, because we are a hairless animal and all the other animals around us in the cold are very hairy. What you have to do is you have to take their fur and put it all over your own body. There are boots in Siberia that are made directly from the shin fur of reindeer. So there's an inner boot, and that's short fur because it's taken from a reindeer killed in July.
Summer fur.
In summer, so their fur is their least because they're actually trying to lose heat all the time. Because they hate heat. That's what the antlers are doing too. They're a kind of radiator.
Yeah.
And then over that, you have an outer boot, which is made from fur killed in November, when it's at its thickest. And even your sleeping bag is made the same way.
It's hard to believe anything grows here that the reindeer can eat. But there are small bits of edible plants under this snow. And these get exhausted pretty quickly. When they do, it's time to pack up and find better grazing land, or return to their villages until the snow clears. For the reindeer and their keepers, this cycle of seasonal migration makes life possible. The Chukchi offer Niobe and us a glimpse at our ancestors' ability to adapt, innovate, and rely on each other, even in the most challenging of environments. Could these traits have given Ice Age humans a survivability edge over the Neanderthals?
When the times are rough, social networks suddenly become extremely important. It's very important if you can go to the next group over and somehow be connected to them and somehow be taken in or helped out.
Homo sapiens may have had another advantage. Like the Chukchi, they carefully crafted cold weather clothing.
Clothing was one of the most important innovations brought into Europe by modern humans. But that was made possible by one of the most important artifacts ever invented, the eyed needle made of antler or ivory, which enabled people to sew clothing and fit it to people.
But perhaps the simplest explanation for our ancestors' survivability may be their greater numbers.
Modern humans can reproduce extremely fast. The result of that is that human population expansion is very quick. What we know about Neanderthals is not only are they living in small groups, but the overall population seems to have been extremely small.
By 40,000 years ago, the Neanderthals, Denisovans, and all other archaic species were, for the most part, gone.
There were 4 or 5 species wherever we went, but we were the survivors because we brought with us very sophisticated ways of looking at the world, division of labor, very extensive toolkits for hunting and gathering, and gradually, I don't think it was a holocaust, I think that in terms of a model, I see us displacing people.
By 25,000 years ago, we had reached all the lands between the Atlantic and the Pacific, including the Arctic. And we're poised on the cusp of a vast new territory. By now, the last great ice age had reached its peak, and the world became even colder. As the seas froze and ocean levels dropped, a new land appeared in the waters of the Bering Straits that would eventually connect North America and Asia. This land called Beringia would last at least 10,000 years, and for long stretches may have looked like the cold, rocky landscape of today's far eastern Siberia. Here, another Arctic people, the Yupik, live off the land, or in this case, the sea. And they travel over and through the icy waters in another echo from the past, the skin boat Umiak. When the sea freezes solid, people can walk or sled across the ice. But when the ice breaks up, the Umiak is light enough to carry and sturdy enough to row, a perfect Beringian vessel. Making one is a fairly quick operation, and Niobe joins in. Up here in the Arctic, every resource is precious, so all the wood in this frame has probably had several lives already. This could have been a door frame once. Now it's about to go out to sea. When the boat's frame is ready, it's covered with a single walrus skin. Shaved so thin, it's almost transparent. What's remarkable about this kind of boat is that every part of it can be found in a completely treeless landscape. Skin, driftwood, and bone. Many experts believe the first people to enter North America did so by working their way along the Bering Land Bridge in skin boats just like this. They may have even trekked at least part of the way across when ice didn't block their progress. Regardless, by 15 to 20,000 years ago, our ancestors set foot upon a land no one but animals had entered before. Although archaeological and other evidence pointed to America's first people crossing the Bering Straits from Asia, discoveries of ancient artifacts that appeared European in origin led to a counter-theory, that the first Americans actually crossed the Atlantic, not the Pacific. And beyond the scientific findings, many Native Americans believe they are neither Asian nor European. That their people have always been here. In 1968, a chance discovery in the hills near Bozeman, Montana, would begin a 45-year saga that finally unmasked the origins of America's first people. Sarah Anzik was just 2 years old when that discovery occurred on her family's land.
What I've been told is that these construction workers who had received permission from my father to extract landfill for a local high school project were actually just digging the dirt out, and one of the construction workers noticed one of these giant artifacts that had come tumbling out from the site.
To their amazement, they would unearth over 100 stone and bone artifacts, all about 13,000 years old. Shane Doyle is a Crow-Indian historian who has studied these artifacts identified as belonging to Clovis people.
The Clovis culture had a very distinctive style of fluting that they used to make their spear points and their arrowheads. So you can see how it's been fluted down the middle here and would actually be attached to a larger wooden spear point. These were all the tools that they needed to get by on a daily basis by hunting and gathering. They were hunting everything from woolly mammoths to bison. And so they needed these. These were its most precious commodities as far as survival goes.
But why did they bury such valuable and important items? The answer soon became clear. As the men dug below the artifacts, they were stopped in their tracks by a young boy's skeleton covered in red ochre. They had chanced upon a burial site of one of the oldest human skeletons ever discovered in North America. As a child, Sarah Anzik was hardly aware of the discovery's significance. But she became a molecular biologist, and in the 1990s was working on the Human Genome Project when she realized an opportunity to discover the true origins of Native Americans might lie with DNA from the Clovis child's skeleton, now carefully stored away.
And I started thinking about, well, you know, we have an ancient remains that's 13,000 years old. And so I kind of began to put two and two together, thinking, wow, you know, wouldn't it be really neat if we could take a glimpse into the ancient past through the genome sequencing of this ancient individual?
Sarah decided to contact local Montana tribes to see if they would have objections similar to those voiced by Native Americans when scientists tried to recover DNA from the Kennewick man. The discovery of a 9,000-year-old skeleton in Kennewick, Washington, had triggered a contentious legal battle. Native Americans said the bones were sacred and should be reburied, while scientists wanted the knowledge their DNA could provide. The battle was ongoing when Sarah approached the Montana tribes asking to do DNA studies of the Clovis child.
One of the tribes was quite supportive and interested in my findings, and the second tribe, on the other hand, were not.
Sarah decided to go forward anyway, but she had never worked with ancient DNA, a far more difficult process than sequencing fresh DNA. So on her own time at a private lab, she began practicing on old animal bones and failed.
And so at that point, given the challenges and the obstacles and the heated debate with the Kennewick man, I just put everything aside and took a rest.
The hiatus would last 10 years. But in 2009, over in Copenhagen, DNA hunter Eska Villisju, who had been so disappointed with the school cave tooth results, was asked by Sarah to lead a new effort to recover the genome of what was now being called the Anzik child. The Copenhagen team, with Sarah joining in, went to work. Unlike the much older school sample, they were able to get strong DNA signals right away. They focused on recovering DNA from regions called haplogroups, strands of DNA sharing common mutation patterns that go deep into the past. They then compared Anzik's distinctive patterns to the genomes of nearly 150 modern populations around the world, and to a few ancient population samples previously decoded. It took the team 4 years but they finally narrowed down exactly where the genes of the Anzac child had come from.
These findings were really significant for, one, that they refuted the Solutrean hypothesis, where the first Americans came across the Atlantic and they're European in descent. They're not.
As expected, major elements of the Anzac child's genome came from across the Pacific. 1/3 of the boy's genome matched genes from a 24,000-year-old Siberian skeleton. So he's part ancient Siberian. His other genes matched those of ancient East Asians. So 2/3 of his genome comes from them. But this specific genetic combination can no longer be found in any living populations west of the Bering Strait, only in living Native Americans east of the strait. So what does this mean?
So basically you can almost imagine, you know, these two very distinct groups of people meeting each other, interacting, and you can say the child of those, if you want, is actually, genetically speaking, Native Americans, right? And then the question was, when is this happening? Where is it happening?
What we believe is that there was a cross between Eastern Asians and Siberian up in the Bering Strait, and they crossed over the Bering Strait and populated the Americas.
So from the edge of the Asian continent, or from the now vanished land of Beringia, the ancestors of the Anzac child came to North America, bearing a genetic signature found nowhere else in the world, and would pass it to generations of Native Americans to come.
That would fit with the idea that you see Native Americans as being something genetically completely unique.
Back in Montana, Sarah and Eska were nervous about releasing the study's results, wondering what Native American reactions would be.
We didn't want to publish without some communication to the local tribes to tell them of our findings, because we didn't want them hearing about this for the first time through a publication.
They invited Crow historian Shane Doyle to the discovery site to assess his reaction to the study and their findings.
It feels really good.
We met him at the Anzac site, and he knew nothing about this, what we have found, and he became extremely emotional. And he took out his drum and he started playing a song.
I was really overwhelmed with emotion. The results show that American Indians are from America. We don't come from any place else. Nowhere else in the world is there Native American DNA except for the Americas.
But Shane told them the tribes would now want the child reburied.
We understand that the study's been made and we can't go back in time now. And so I think you should put the boy back. He's given us all this information, and now it's time to return the favor and put him back where his parents left him, where his grandparents shed tears for him, and it's just the right thing to do.
On a rainy fall day, representatives of various local tribes joined in the solemn ceremony to return this special child, their most ancient relative, to his original resting place. Initially, Sarah and Eska had misgivings about Shane's request to rebury remains that would be lost to science forever.
I had a huge conflict. I had a scientific community who was telling me how important this was. And then I also had the Native American communities who were also very passionate about seeing this child go back to his resting place.
It had been a long and emotional struggle for Sarah Anzac. But in the end, she did what she always knew she would.
From the first day that I set eyes on these remains, I had always felt like it had a story to tell, you know? And I just felt like it was important
that this child had the chance to tell his story.
And as it turns out, the child called Anzac is far more significant than anyone could have imagined. Close to 80% of all living Native Americans carry his genome. And that percentage is even higher in Central and South America. This means the descendants of a single band of Ice Age hunter-gatherers who crossed the Bering Straits around 15,000 years ago would eventually create virtually all the great civilizations of North and South America that flowered long before European contact. By 5,000 years ago, there was just one frontier left for humans to conquer: the mighty Pacific. Almost 10,000 miles wide, the Pacific Ocean covers about a third of the Earth's surface. Its islands are like grains of sand scattered across a vast blue void. Yet somehow, early humans managed to reach them all.
These are distances that are greater than the distance across Europe. The whole settlement of the Pacific really is something that's under-celebrated and undervalued in terms of representing, the capabilities of these people thousands of years ago. They did an amazing thing.
In the 18th century, when England's Captain Cook arrived in the Hawaiian Islands, he found people he called Polynesians had been there long before him. How was this possible? Cook needed navigational charts and full-masted ships to reach the middle of the Pacific, while Polynesians had less sophisticated-looking boats and sailed with no charts. So how did they reach specks of land in the middle of a 10,000-mile-wide ocean? Some experts believe the first people to reach Pacific Islands drifted on crude boats pushed by trade winds that blew west from South America. This theory of accidental drift originated with Thor Heyerdahl, a visionary Norwegian explorer. In 1947, Heyerdahl and a small crew set off from Peru to prove his theory. The men built a balsa wood craft called Kon-Tiki and just drifted westward on the currents. After 101 days, they crashed into a reef off a tiny island in the South Pacific. Luckily, no one drowned. It was an extraordinary adventure that embedded in the public imagination the idea that humans from South America settled the Pacific. But was Heyerdahl correct? Anxious to learn more about the famed explorer, Niobe traveled to Oslo to meet Heyerdahl's son.
Well, the funny thing with my father was that I'm myself a traditional academic. I'm trained to collect samples, data, analyze it, and draw conclusions from what I've found. My father, he jumped to the conclusion first. He was in many ways also an artist with imagination. He started with the conclusion and worked his way backwards like a lawyer defending his suspect.
To Heyerdahl, his main idea was those people came from South America, the Polynesians and those guys, because they were sitting in the wind with their boats and the wind would blow them to the northwest. A completely anthropocentric European idea.
And wrong as well. Recent genetic studies of Pacific Islanders reveal their origins are not in the Americas, but in Asia.
If we look at the Polynesians and their other, close relatives in Micronesia and parts of eastern Melanesia, they share many of these genetic traits all the way back to Taiwan. So a lot of the genetic evidence that's emerged in the last 2 decades has helped to reinforce the picture that archaeology and linguistics have been giving us for quite a while.
That archaeological evidence reveals human populations migrated into Southeast Asia, and by at least 40,000 years ago, had managed to reach island groups such as Indonesia and the Philippines, perhaps when sea levels were lower, narrowing the channels.
For early humans crossing the Asian continent, this should have been the end of the line. Southeast Asia, on the edge of the mighty Pacific Ocean, an impassable barrier to the further colonization of the planet. Except it wasn't really a barrier. Just like for these Philippine islanders today, our ancestors found ways to live with the sea, and soon they were crossing it.
The wonder is that Heyerdahl and other experts could not see the obvious. There are perhaps no other cultures as comfortable at living with the sea as the inhabitants of the Pacific Islands. That they, and not people from South America, would conquer the Pacific now seems obvious. But how exactly did they do it? The first thing they needed was the right kind of boat. There is no archaeological evidence of the earliest boats, but there is one place that might offer a clue. Papua New Guinea, the world's largest tropical island, which lies just west of Indonesia. The immense Sepik River drains a tropical wilderness. Here, humans live in a labyrinth of streams and swamps. And they travel throughout in dugout canoes, a vessel that probably has been in use for tens of thousands of years. And these men are still making them as their ancestors did many centuries ago.
How long does it take to adds out the canoe like this?
It takes 1 week.
Who's the carpenter of this boat?
That's my elder brother.
The craftsmanship of the canoe makers is extraordinary. Over time, Papuans took the dugout to astonishing extremes. By making war canoes that were long and fast.
The Papuans have very long dugouts, and that is a very clever idea because every sailor knows the longer your boat, the faster you travel. The Papuan peoples, as far as I know, never had any sailing boats because they did not venture into the sea. Those canoes will capsize.
Canoes are best in calm waters, not in ocean waves. So island people added an outrigger. The outer rig widens and stabilizes the boat's thin hull, so waves hitting the boat from the side can't easily tip it over. And with a sail to catch the wind, these boats could move easily and swiftly between closer islands. And, as it turns out, they could indeed sail into the wind, putting to rest Heyerdahl's idea that they could only drift with the wind. Wind tunnel tests on a model of an ancient Polynesian vessel clearly demonstrate they could tack, which is how sailboats sail into the wind. As sailors head into the wind, they steer the boat from one diagonal direction to the opposite diagonal. Crossing the sails over allows the wind to push the boat forward on a zigzag path, something every modern sailor knows. So island hopping by outriggers throughout the southern Pacific settled this region fairly quickly. But it's many miles of open ocean to mid-Pacific islands like Hawaii, a perilous trip for a small outrigger.
Somebody probably around 2,000, 2,500 years ago gets the idea, aha, I get rid of the outrigger, I bring another canoe hull in, I put them together, right, and I've got a catamaran, basically, a double-hulled canoe. And that was then the platform that allowed an even greater phase of expansion.
A catamaran is still one of the best sailing vessels in the world. Swift and stable, with enough deck space for crew and supplies. This double-hulled replica of an early Polynesian catamaran, called the Hokulea, is certainly sturdy enough for long ocean voyages. But how did early Polynesians navigate their immensely watery domain? Kalepa Babayan is one of the ship's senior navigators. He sails the Pacific without charts, GPS, or instrumentation of any kind, just as his ancestors once did. He learned this extraordinary skill from the last traditional navigator, a legendary sailor named Mao Pialak. Now deceased, Mao was living on a remote island in Micronesia when director Sam Lowe captured him on film.
Mao Pialak was one of a handful of navigators who still practice the ancient art of non-instrument navigation. The ability to use the rising and setting points of stars, being able to find your way across thousands of miles of ocean with no instruments, no charts, with no assistance at all from anything other than what he had memorized.
This footage shows Mao teaching these young men how to navigate by the night sky. These lumps of coral represent the rising and setting points of highly visible stars. The star called Mylab, the Big Bird, is the first to rise in the east and the first to set in the west, defining 2 compass points. Since the axis of the Earth always points north, toward the North Star, by memorizing the position of the other rising and setting stars, the navigators always know where they are. On cloudy nights or in daylight, Mao teaches the young men to read swells and currents to keep the boat on the desired path. These are timeless navigational skills that enabled their ancestors to master the mighty Pacific.
To set out in a canoe 1,000 years ago would have taken an almost superhuman race of people to be able to endure that kind of voyage. The ocean was always their road. Going to sea for a sea people is one of the most natural things that you can do.
With astonishing navigational expertise, Pacific Islanders moved swiftly and systematically across the ocean. From islands east of Indonesia, beginning about 3,000 years ago, they moved east, south, and north, settling one island after another, finally reaching Hawaii, probably around 1200 AD. To Lisa Matiso Smith, this is nothing less than extraordinary.
what it tells us, this instantaneous kind of dispersal and continuous successful settlement from that point onwards, is that these people knew what they were doing. These people were prepared. They know where they're going, and they know what they need to survive when they get there. They did an amazing thing, you know, in being able to navigate. And I think we're beginning to value that and recognize that skill.
Probably the last Pacific island to be settled was Easter Island. Over 1,000 miles from the nearest land, it was once thought to be as far as the Polynesians could sail.
The Polynesians who settled here had sailed to the most isolated inhabitable speck of land on the planet, and then they transformed this volcanic rock of an island into a landscape full of their ancestors.
According to island traditions, these iconic stone figures, called moai, are revered images of their ancestors, charged with sacred power. At the height of the statue-building cult, several thousand people lived on the small island. Although it's a whopping 2,500 miles from Easter Island to South America, could Polynesian sailors have launched a journey from here and reached the Americas? The possibility the Pacific Islanders did rests on two pieces of evidence. First, the ordinary sweet potato.
And the sweet potato, there's no doubt, it's a plant that was domesticated in Peru in South America, but it was in Polynesia when Europeans arrived.
And we know that it was in East Polynesia. We have archaeological charred remains that are dated to about 1,000 years ago.
So how did this plant that evolved in South America end up on Pacific Islands thousands of miles away?
Somebody got to South America and brought this sweet potato back.
That the people who brought it back to the islands were Polynesians rests on a second piece of evidence, recently uncovered in Chile. Here, Dr. Jose Ramirez Aliaga is about to show Niobe that discovery, which may prove once and for all that Polynesians did reach South America long before the Spanish.
I want you to see this fantastic material I found here in the basement.
He follows Dr. Ramirez Aliaga to a storage room, where he's shown a box of ancient skulls.
Did you know this was here?
I didn't know, but until a month ago.
So it was rediscovered?
Exactly.
The skulls date from about 1,000 to 1,300 AD. They were discovered a century ago on an island off Chile's coast, but were stored away until Ramirez Aliaga found them. He believes the skulls are Polynesian because of their unique shape.
Okay.
I'll follow you.
All right. Follow me.
What tells you that this is a Polynesian skull, possibly?
In that time, the evidence was the pentagonal shape, the roof shape in the top of this cranium.
So a flatter top and then...
No. This kind of shape here, which makes vertical sides, and this like roof, double roof on top.
So it's the pitched roof
form. Our skulls in South America, the Mapuche, is round, completely round.
So not round like a South American, but pentagonal like a Polynesian, and someone who lived a hard life.
This guy has terrible diseases, actually.
Where do you see evidence of that?
These holes sometimes are related to some anemia.
Right. So some kind of a dietary deficit.
Yeah, exactly. Yeah. Another trait which is very interesting is this muscle attachment. Yeah. Very strong. People who work very hard with the necks.
Ah, okay. So carrying things with the neck and...
I mean, not carrying, pulling.
Pulling.
With the head. You know.
Right.
Terrible. So they have muscles like a bull.
Right.
From here to the shoulders.
Right.
Although the Chilean skulls do not definitively prove Polynesians reached South America, coupled with the spread of the sweet potato, the evidence is mounting.
I have no doubt that Polynesians made contact with the Americas, and I think, there's strong evidence to support that.
If Matiso Smith is right, long before the more celebrated European voyages of discovery, Polynesians and other native people had crossed the entire Pacific, shore to shore, and landed on its islands as naturally as seabirds. Back in Hawaii, Niobe wants to meet Kalepa Babayan, navigator of the Hokulea.
Hi. Hey, welcome aboard. Hi, nice to meet you.
Kalepa was just a teenager when he learned the art of traditional navigation. And now he is preparing himself and his crew for a sea journey far longer than any of his ancestors undertook. They will attempt to circumnavigate the globe. And for most of this epic journey, they will use only the traditional techniques of the master sailors of the Pacific.
We have the external compass, which is made up of all the natural clues, the stars rising, stars setting, right? The moon, the planets, all rising from the one horizon, and then the wind and the ocean swells. The wind and the oceanic swells all come from the same horizon. They all come from the east. You just gotta internalize that rhythm and understand what direction they're coming from. We're very competent and very confident navigators. We know the Pacific real well. We know we're not going to sail off the edge of the earth, so it's good to know. Navigation is 24 hours a day, 7 days a week. From the time you take the ropes or pull your anchor to the time you arrive at land, you're constantly navigating. You only know where you are by memorizing each and every second where the canoe is traveling. So you've got to be able to internalize the clock of the universe.
On May 18, 2014, under the Hawaiian flag, Hokulea embarked from Oahu on its 3-year circumnavigation of the globe. The journey will cover 47,000 nautical miles, with stops at 85 ports in 26 countries. Kalepa's crew will live on this open deck for months at a time. As they prepare the Hokulea, they are also preparing themselves. Of the Hokulea and its crew, this journey will demand everything. We are finally gaining a more complete understanding of the heroic scope of our very own story.
Yeah, but does that fit with this?
Every chapter in that story is being enhanced by groundbreaking scientific discoveries all over the world. A new set of human remains, for example, has been recently unearthed in the Rift Valley that will, for the first time, provide us with a nearly full skeleton of one of our earliest ancestors.
This is the ear hole. This is the kneecap. We found both of them. This kind of discovery from head to toe is very rare.
Look at this, the elbow. Big guy, very big guy.
And with more analysis, these bones could turn out to be among the most important Homo sapien remains ever found.
For sure, these are the people who, at about 100,000 years ago, that left Africa and populated the world.
From small groups of hunter-gatherers living a precarious existence in Africa, our ancestors would eventually reach every place on Earth. An epic, often harrowing journey, an achievement almost impossible to imagine.
We have always had this idea that man back in time were primitive. What you really find out, they were capable of amazing things. They are adventurous, just as we are today.
Homo sapiens is a crazy animal. They do things which you don't believe are possible.
We are all related to this early Homo sapien. Those different types of people that you see all over the world, genetically, we're almost identical.
And as a species, our fates will be forever intertwined.
We evolved from someone like Lucy, probably, who was very closely tied to the natural world, to a species that all of a sudden is in charge of the Earth, of the globe.
Our powerful mind got us this far. But what lies ahead? Are we clever enough for the changes to come? In evolutionary time, we're young, only about 200,000 years old. Will we continue to evolve, or will the Homo sapien line die out with us?
We're the first species on the planet that has ever been aware of the possibility of its own extinction.
We're not indestructible. There are evolutionary dead ends. There are some species that don't survive.
We are the single most adaptable creature. We can sit on top of a rocket and shoot ourselves into space. We are incredibly adaptable. That is hopefully our salvation.
Our salvation could be in our very name, Homo sapiens, a human of the mind.
This Nova program is available on DVD. To order, visit shoppbs.org or call 1-800-PLAY-PBS. Nova is also available for download on iTunes.